Yeah, so first question is stream of characters. So we have to implement this class as follows. So there is a constructor, any data structure with the given words, and letter will be passed in this query, which will return true if only if for some k greater than or equal to 1, the last k characters are queried in older from oldest to newest, including the recent, just queried spell on one of the words given in the list. So like this is the list that they have. If it's already present there, think it like in a try or something. So if we check A is not there, then we'll check B is also not there. And then we'll check whether AB is there. AB is also not there, it's false. Now coming to C is also not, C is not there, right? Neither BC is there. Pardon?
What is the K value here?
K greater than equal to, they haven't mentioned anything K. It's greater than equal to 1, they told. Returns true even only for some K greater than equals to 1.
Yeah, K is just an indicative value. So
yeah.
But okay, so you have to go all the way through, like for every.
Like when you are at D, right? D is not there, but CD is there. So CD you will return true. But again, BCD is not there. If any one of them matches for K greater than or equal to 1, will return true. But ABCD is not there. BCD is also not there. Only CD matches. So, and if you go to F, since F itself is matching, so you return true. And EF, BDF, all this will never match.
So when do you return true? When
any of them matches in your this list, either the combination or alone itself, like prefix.
No, but it's not about that particular character matching. It can be a contiguous sequence also, right?
It could be, yeah, but worst case, like F you see here, like only this is there, only F is matching,
Yeah,
right?
this is the best case.
Yeah, best case. But here if you check, CD is matching. Alone D will not match, but CD will match, so it will return.
Yeah.
And
sliding window kind of, right?
And,
so it is the latest in the stream. So whatever, now if you are at F, right?
Yeah.
So imagine this whole is a stream, like even they are saying it's query.
Okay.
So we are getting stream characters, like we get A first, then we get B, then we get C, and then we get D. So immediately at D, we can go from D to C, and then find out how much of them match. If they match, then immediately return it. So if that is returned, then you can actually throw this whole stream, whatever was the earlier one, and then you can start with a fresh one. Like you start from E. Okay, E doesn't match, then you go to F because F will come. So F is there. If it matches, then you return. So you can again throw E and F also to do an optimization, or you can just keep it. It doesn't make any difference. Yeah. But every time, whenever you are at a current location in the query, so from that character, you go back as much as possible till you don't find a match. So the best way would be like if this initial character, if it is not present in that whatever your data structure is, so you should be able to return as quickly as possible.
So you reverse the input and then store, so that it will be better than if you reverse this and store and then check.
Right. So that would be the most efficient way of doing it. So therefore, what will happen is whenever, because usually you'll start searching for any value from the end of this stream, right? So means whatever is the current one. So if that character itself doesn't matches, it doesn't make sense to go ahead, correct? In the whatever that data structure. So at least you are saving some time on the query part.
Yeah, by reversing that list. Yeah.
But it says that you have to check from the oldest to the newest.
No, but it should be included. The recent one should be included with it. First, you check whether the recent one is present. If not, then you check these two. Then again, you go one step BCD. Then again, one back. DCB, ABCD.
So I thought first you'll check ABCD, then you'll check BCD, then CD, and then D.
No. From back you have to go D, DC, DCB, and DCB.
Yeah.
The recent.
In that case, what will happen? See, if you have gone to A and you didn't find anything, right? So you have already checked A. Now when you come to B, so you will check B. If B is there, it's fine. If it's not there, then you just immediately come out. But if you find B, then you should check for A also, right? Or if you just find b, you'll return. But if
Yeah.
you don't find b, and actually if you see there is a source for b, okay, which will end it some other character, then you will actually go at the previous one, which is a. Okay, then you will try to see if b a is matching. So if you take the
Mhm.
example of cd, right? So you have accumulated a, you didn't find anything. You go to b, you didn't find anything. You go to c, but c also there is nothing. Okay, you do still have a cd, but c is ahead of d, correct? So you
Yeah.
still have to wait for d. So whenever you get to a d, okay, so you know that you can start a stream, though you cannot directly return. You, even if you find d, you cannot directly return because it is associated with c in that case in the data structure, correct? So
Makes sense.
therefore
Yeah.
you still have to go in the stream from d to c and see if it matches the whole string cd. If it matches, then you return.
Yeah.
Yeah, so that k actually is just an indicator. So they are saying this k number of characters, right? Either that will be one number, at least a single character, or maybe more than one, right? So that is what they mean is like when we actually start from a, so at least it's character one. If you find it, that is k is equal to one. Okay, if you don't find it, then it's fine. But when you come to d, you can actually, the k becomes d, a, and c, so it will become k will be 2. So something like that, but that actually you don't get, they don't give any input, something like that in our signature function also. I'm just trying to explain what it should be.
Yeah, that makes sense.
Uh, I want to ask something like we are making the reverse of a word and we are making a try with that,
Yeah.
right?
Mm. Yes.
So in this case, like if I have the query, let's say I do not have the word CD, instead I have only D. Uh,
So
okay,
is
and
okay.
I
Yeah.
have D, and I also have CD, let's say.
So if
So my
CD is like,
try,
you want to annotate?
yeah,
Okay, wait. So like if I'll store it like DC and I'll mark that this is only the final. Once you reach at this point, this will be your final word. This is your error.
in no, like if I have both D and CD as the words, and
Uh,
my query is A, B, and then D.
A.
Like try try does handle, like I haven't used it, so like try, will the try be able to handle only a single letter also?
Yeah, I mean here it will be marked is and or equal to true. So if it matches
Okay,
only with the it will return.
okay, okay.
Yeah, in that
Yeah.
case, you'll have a D as a word and CD also as a word. So whenever you come to A, you don't find A, you just go to B. If you don't find B, then you come to D, right? So as you
Hmm.
soon as you come to D, you see that D is a word, so you return true immediately.
Yeah.
Yeah, that's right.
So almost we discussed only, right?
Yeah, because actually this problem, I don't think so. You can implement with any other data structure, right?
Hash map.
So, huh, yeah, but see, the
It's
thing
like
is,
Yeah, I tried doing hash map and it was taking too much time. Like,
but at least you are able to implement, right?
like I, I was not able to implement it. Like in between, I knew like this would take more than what,
right.
like more than what they will allow,
Oh, okay,
more
okay.
time.
So you mean to say the solution was not getting accepted by the lead code? It was something tailing, right?
I didn't actually write it completely then.
Uh-huh.
So and yeah,
Yeah,
No,
yeah,
yeah, no problem. But yeah, definitely. I mean, space we are optimizing with the help of try. Therefore, I don't think so. Solution will pass with hash map. Just thinking loud, but couldn't be.
yeah. It looks very try-centric question, most
Yeah,
of it.
exactly.
Right, yeah. So if actually it works with try, why to go with something which is actually slightly cumbersome to implement, right? That is it comes to everyone's mind. Right?
Yeah.
Yeah, even though try is not a very day-to-day data structure, but now it's most of the string related questions, they involve try to some extent, right? So you can
Yeah.
always think of it. And I'm sorry, I'll just fix my mic. You go ahead, Sehan.
Yeah, no problem. So here, like normal, typical, I mean, as we do, this is a try implementation. So each end of the word will be false and 26 letter A to Z. And whichever, let's say you took the whichever letter you take, you check whether there is a branch for them. If there is no branch, then you create a new node at that point and just point this T to that, what to say, that node. And just once all the like C you put and D you put. So C and D already you put in a branch of a try. Now at the D you need to put A. This is the end. I mean, once you reach D, that is considered as the end of the word. And this is for the search. Again, normal one. Like if you find it's none, you return false. Otherwise, you keep the pointer on the first one and just keep on doing the, what do you say, till the point you reach the end of the word. If this is true, then you return true. Otherwise, it will false. For every character, you keep on doing that, right? Yeah. Am I audible?
Yeah, you are audible.
Okay. Okay. Yeah.
Yeah.
No, I didn't get acknowledgement. So thought
No,
that.
no, you are right. So I was just trying to look at the way you are doing. So your init and this what you say query becomes more easy, right? So the
Yeah.
try is the standard template what you are using, correct?
Mhm. Yeah. Yeah. Yeah.
Okay.
The 26 letter and just normal. If it is not, if there is a no node with that letter, create a new one and keep a pointer and till the point you reach the end of the word, at last you just make it true. And for searching, same thing. If you find no node exists with that letter, you return false. Otherwise, you keep on going down. Once you find, hey, this is the end of the word, you return true, else false.
Right, right. So if you go to that init function, right, in the stream checker,
Okay, okay.
and then you initialize a try.
Try, yes.
Okay,
And
so
this
then
is
you're keeping this stream of DQ.
so that I can take it from the front. I mean, I can append it to the left. I mean, from front I can append, right? In the
Mhm.
DQ, double-ended queue. And I'm storing all those words in a reverse manner, which I explained, like DC fashion, F
Mhm.
and L. And this is as per the queries coming, just append it from the front and then pass it into your, what you say, search function. It will search. Depending on if it is found, it will return true, else false.
Yeah. So now the implementation of these stream checker becomes very straightforward and very simple because you are using a try,
Hmm. Yeah.
right? So only one small optimization I would say, see in this
Hmm.
case, when you are going on the line 33, when you are inserting and you are reversing your word,
Okay.
right? So see, your reversing itself is going to take whatever is the O of that particular size of that word, right?
Yeah, O of n kind of, or O of
Right.
size of a
Yeah, size of it's not going to be O of n because we don't know what actually O of n should be, right? In this case also, it might be the query size. You never know.
Yeah.
So I was saying, in your try implementation, you just pass this line 33 as is without reversing your word. But when you go to your try implementation in the insertion part, can you just scroll up? Yeah, in your insertion part itself, you don't start from the first word. You start from the last letter in that word. You know, so it will automatically get reversed over here because there you just have to look for the index of that word, right? As if you are starting from the back side of your word. So then you don't need to do a literal reversing of your word.
But okay. But I mean, in try it will be like CD, right?
Right, right. So see now in this insert you are doing exactly following the standard template. That's perfectly right. It's no problem. But if you use the same thing over here and just start from instead of starting from 0th location like this on line 10, the C character represents the 0th location of a word, right?
Mm-hmm.
Right. So you start from the first. So if it is like something word like we take something like India. So I will be the first one, right? INDIA. Instead of that, if you start from A, which is the last letter, so it will be reversed. The try will be a reversed implementation.
Yeah.
So that's a small optimization.
Yeah.
Yeah.
I'll try to implement
That's the only small thing. The rest everything actually is perfect.
that. Yeah. Then we can move to next.
So, Shashank, I have one question.
Go ahead.
You have taken a DQ, right?
Yeah,
So,
DQ I've used.
but I mean, are you pushing at both the ends?
No, from front I'm taking. Up and left means from front side of the queue.
And where are you popping from?
I don't need to pop. I'm not popping anywhere, right? Because you have to. I'm not. You have to check stream of characters, right? Like every character, there is no need to pop it. Otherwise, how will you check AB previous characters? A, B, C. I mean, you got right.
Right. So, can we use a stack also? I mean, because you would always push on the top of it, and then um, I was just
Uh,
curious.
okay, if the stack you will use, you will put A, B, and then C here should work, right?
Yeah. Stack also
Should.
may work. Yeah. Why
Should.
not? But the only thing I think, why he was using DQ, you can still have an optimization on the stream front also. So whatever that stream is, you keep on collecting. Like if you see, look at this example, when you push A, you don't find anything, you just keep it. You go to B, you don't find anything. But on C also you don't find. But when you get to D, you find CD, right?
Yeah.
So at that time, you can actually flush out the whole stream because you have
Okay.
found one word, because then you are starting with a fresh one. So you can do an optimization there, because that is what there are a lot of discussions in the, because what happens, the stream will grow or the DQ will grow to such a huge extent if you have so much of queries.
And then it
Oh
will
yeah,
work.
yeah. You're not flushing it, right?
Yeah, we are not flushing, but we can do that. That is what the people are discussing, but no one has a very good answer on that. But if you do that optimization, it works fine. But I think Leetcode is not paying attention to those type of test cases.
So you are suggesting that after the first match is found, A, B, C, D, um, right after D returns true.
Yeah. So whenever you find a match, immediately you just discard all the whole of the stream and start a fresh one.
From there, yeah.
So will it work if two words in the input stream of words are like one word is a uh, prefix of the other? Say leet and leet code, right? They are two words.
Also, you're
Sure.
saying if lead is already inside,
Yeah.
okay, and then you get a code. So you don't have a code separate word, but then you have a lead code.
Yeah.
Okay, yeah, that's a very good question. Yeah, then you we'll have to take some judgmental call on that. So we might have to ask more clarification questions and see how the stream formation is. Yeah, because that might be one reason actually. It's people are not fleshing it out, and lead code is also not paying
Probably they
more.
may have given some constraints below, right? I'm just guessing. Nothing.
Nothing much, but it's only the word length. Nothing about the queries. They say it's a 40,000 number of queries.
Right, right, right.
Yeah, maybe that's also not too huge, right? So
Yeah.
just keep, because yeah, what you say makes sense, because if you have that lead and lead code, these two words, and then when you pass on lead and you just remove it, but in that case, yeah, so still okay. In that case, you still have that word in the try, right? We are not removing any words from the try, but if you remove it from here, yeah, we'll have to make something like, okay, we have visited this word, then put something like a visited in the try somewhere account or so, and then come back again. I don't know. Yeah,
Yeah,
maybe.
yeah.
a dirty way of doing it. Yeah.
So next is largest number, right?
Yeah.
Okay. So here we are given list of non-negative integer nums. You have to arrange them such that they form the largest number, like this one. I mean, if we take 102 or 210, which is bigger, 210 is bigger. The result may be very large, so you need to return a string instead of integer. Okay. Yeah, again, this greedy won't work, like people, if you think of sorting and then.
Yeah, so we can try out every combination,
Uh,
like every
You can
permutation.
sort by the first digit, right? And then in descending order, and then add it.
that is sorting only, you are saying, right?
Yeah,
Sort the
you
array
sort.
and
Yeah, sort the nums into, like, you see 9, right? 9, and then first digit is 9, second digit is 5, third digit is 3. Say out of the 3, if you have second digit, then you go with if it has um, first place of the second digit. If it's 4, then use that one, and then whichever one is not having, then like that. So that way uh, you can sort it and then iterate through the first digits, and second digit you can put like that.
A custom. Okay.
So what if
sorting
there
operator.
was a 55?
both the digits,
What if
right?
there's 55?
So what I'm saying is after 9,
Yeah,
yeah.
after 9, if you have 55, right? So it will still be 9. 9 is the greatest number, and then you have 5 and 55, right? If 55 is also there, it's somewhat like 3 and 3 30, right? So which one comes first? 3 comes first. So 5 comes first, and then 55, like that.
Okay.
Yeah, if
And
it's
then
a
you'll
2-digit, yeah, that is right. So that will come first.
yeah, if it's and if it's 3 digits, then the same logic you can use. Whichever one is the maximum. If you have 365 or something, then you can add 9 first, and then you can check for 3, and then after 3, whichever is the first digit. If it's like 3 with nothing, 3 with 0, 3 with 4, and 3 with 365 or something, then it will take 365 first, and then 34, and then 30, like that.
Yeah.
That is my intuition of when I saw this. I didn't solve it, but that's my intuition of how I would go about.
But that's good actually, because that is what the example 2 also follows, right?
Yes.
Yeah. So you're saying basically first do a bucket sort with all the numbers with the leading numbers. Like you put a 9 in one bucket, then 5, and then when you have a 3 bucket, you have all these 3, 30, 34, and then you
Exactly.
start as per your okay. Makes
Or
sense.
if you can put it, you visualize it as a tree also, right? How that comes like a tree or any sorted thing. You can see 9, and then under 3. So you have 9, you have 5, you have 3, and under 3 you have 3 and 30 and 34, like a three-way tree. And then you will like if you do a breadth first search, or no, depth first search, you'll go with the 9 first, and then you'll go with the 5, and then you'll go with the 3, and with 3 you'll go down and get all the results.
Yeah.
Yeah. Yeah. So so now using a custom comparator, either you use the integers or you can use a string also, right? You
String,
can
yeah.
convert
I
them
did
into string.
it's like every number swapping and then checking whether it gives you the greatest one.
Yeah, if you do that way, then you have to do multiple combinations, and then validate it.
Yeah,
Right.
and square kind of stuff. Yes.
Yeah, so that will go a lot. The complexity will be a lot. This time it will either be n and then log n or something, and log n. Yeah.
So Shang, you're saying that you every time you take two integers and check which of the concatenation would be the larger one.
This is what
Right.
I'm doing. I'm going from back side of the array, and till that index, I'll take
Okay.
pass it to my backside. Last two numbers into the compare function. It just checks str of n1 plus n2 greater than this. Then that's a valid combination. I mean, we are just swapping those two values. I mean, if not, you got my point, right? If it is like giving, then
No, I didn't get it. So if it is
that-
false, so if your and
if this is
n2
false,
plus n1 is greater, then you do the swap.
no. If it is not greater, then I do the swap. If this returns you false, not a false will become true, and
Yeah.
then you swap.
I,
Yeah. So,
I said
Like
n2
Shashank,
plus
why are you
n1.
traversing from end and again what is the J, I and J iteration? I don't get that.
for every ith till ith point, you take your j from 0 to I. Like let's
Okay,
say you
but
give
why?
why
Like, will
in the
you give
sense
me an example?
you could have gone from front also. I don't think so any, because this is a brute force what I'm doing, right? So you could have taken from
Yeah.
front. Like let's say I started I started from here, right?
Okay.
From the length of the nums, and what will happen now? Usually j will go from 0 to I minus 1. So what is your I?
Okay.
So whatever the length of the array, right?
Yeah.
So then it will go from 0 to from 0 to the this position and do all the possible swaps that you can have with this number and check which gives you the greatest.
What is
Okay.
happening? I mean, exactly what.
What if the
What will
last digit
happen?
is 2 or something? Instead of
But
9, if it's 2.
so this is a, I mean, all the possibilities it will check, right? I'm not
Yeah.
saying, I mean, no any such ingenious way I'm using here to do. Playing with all the possible pairs and then just checking whichever gives me the best. Go with it.
Yeah, I think he wanted to verify if the brute force works, right? Is
Like
that?
you're swapping only G, you are not swapping the ith value, right? Like in the sense you are not swapping 9 here. You're swapping only like before values before 9.
Before 9, yeah.
Frankly, he's not swapping anything. He's just comparing.
No, this one I'm swapping number 6.
You swap there.
Yeah. J
But
with J.
what will that do
Yeah,
after swapping? How will be the state of the nums? Like
Oh yeah, you do
how
a
do you
sorting.
want your nums array?
It will be a string. At last time appending, no. I'm converting the numbers to the string mapping and then just use the join operation and
okay,
convert
let's
it.
do it dry run. Let's do it dry
Yeah,
run.
sure. So what is the array? Let's take this array,
Take
right?
something else. This is trivially
Yeah,
sorted.
take that array and we'll do it.
So this is a bubble sort almost, right?
Looks like, yeah, kind of.
Take 9 instead of 34. Just swap 9 and 34.
What are you saying?
I'm saying 330,
330.
9, 34, and 5.
34. This is a bubble sort only. Yeah. I mean, from bottom to top, bubble is coming. I mean, yeah. So I is initially what your length of the array is 0, 1, I mean, 1, 2, 3, 4, 5, right? I mean, one index, right?
Yeah, no problem. Yeah.
Yeah. And your J
Yeah.
will go 0 to.
Oh, but why one index?
4.
How is one index?
That is what he's taking in that range. But when he
No,
comes
no,
to
no.
line J, 4.
Yeah.
Zero.
He has
It will
taken direct length.
go to 0 index only, you know, because I'm going to 0 only. I mean, till 0, I'll go one step back, minus 1 minutes. So I is 4 and J is going from 0 to 4. Okay. So what I'm doing,
No. I is 5. I is 5 and I will go till only 1, not 0. I starts from 5 and goes
Okay,
till 1, 0.
last index it won't take, right?
Yeah, I will start from 5 and go till only 1.
Yeah, makes sense. And your j
Yeah.
will go from 0 to I minus 1, that is 4, right?
4. Yeah.
So now
0
what we
to
are
4.
nums of j and nums of j plus 1, right? These two.
Yeah.
You pass it into your
Yeah, so nothing happens.
Compare function, like 330 greater than like 303. It's false, so nothing happens.
so it will return false. It will return true, right?
Yeah, it will return true. You're doing not. So you won't do anything.
Yeah, I want to. Now I'll take these two then.
Oh, yeah.
These two pairs I'll take now, right?
Yeah.
So these two again, what will this is 39 and
930.
930.
No. You are swapping 3 and 30
No, he's not swapping.
because j is 0. J is 0 and nums of j is nums of 0. No, j is 0. So
No, this
nums
is
of j comma nums of j plus.
no. This is 330 and this will be 303. So it's I don't need to swap, right?
Yeah, you won't swap.
Yeah. That is if not, right? Yeah. That has to be. Yeah.
Then you take these two, right? These two, what will
Yeah.
happen?
Yeah,
You'll
you
have to
will
swap.
I have to swap.
Yeah. So
It's very
what will happen? 9.
3,
Yeah, you
9,
will swap.
and 30. Yeah.
It's fine. Right?
Yeah.
Yeah.
Now you'll take these two, right?
Yeah. 30 and 34.
Yeah, again you will
And now
swap.
30, 34. Again we'll swap.
So you're 34 and this is 30. You are
30.
done.
30.
You don't need to
Yeah.
go further, right?
Okay.
No.
And now
So what
J
did we
has to go till
achieve?
4, right? 0, 1, 2, 3, 4. So that means
so till this
like
one
5 also will be considered.
0 to
Okay.
4.
I minus 1,
Yeah, how
4.
does it
Only
work?
3.
How does the range function work, Shak? You go till the exact value or you stop one before?
Last value you have to stop up to 3 only. You will go 0 to 3.
Yeah.
Not the
0 to 3.
so I
Yeah.
think I don't
Not
need
4.
to go further. I don't need to go further.
Okay, so what did we achieve after this iteration?
After this iteration, we achieved this is our modified array. This is the array till now. I mean, two numbers are sorted, right? 3 and 9.
Yeah, he'll go for further more iteration now, right?
Yeah, till the I mean, at last we'll see that all the
Yeah,
numbers
but
are sorted.
okay.
Or any intuition you are getting out
No,
of
that I
this.
understand. So what was the initial array? Does anybody remember?
Yeah, initial array was
Only the
I think
swap
initially we had
930.
330.
something here. What was it? 330. We changed this to
330,
right.
and then
We
it
have
was
it was
Keep
34.
9 in place of 30 and no. Keep 9 in place of
9
30.
in place of 30.
Okay, 9 in place of 30.
Yeah.
This way. Is it?
No, it's 3. No, before 30, I guess. 3, 9, 30, 34, 5. Like place 9 before 30 in that example too. That's it.
3, 9.
30, 34, 5. 30, 34, 5.
Okay. So what
Yeah,
did we?
that was
30 and 34 got swapped, right? Isn't it? So
okay.
now I will. I will go to 4, right?
Yeah.
And this will again go from what? 0 to I. So 0 to 3 it will go. So now again these two will be checked. 39 is bigger or 93 is bigger. So this needs to be swapped. 9 will come here and 3 will go there, right? 9 and 3.
Yeah.
And now these two. 334 is bigger or 343 is bigger.
343.
This will be 3. And now we are done. We don't need to go. Only 0 to 2 you will go, right?
Yeah.
Now this will get reduced to 3 and this will get reduced to 2. And now what will happen? 934 is bigger or 349. So nothing needs to be done here, right?
Yeah.
And yeah, and now you iteration will go to 2, right? 0 to 1, 1. It will go to 2, go to 1. And now what will happen? 0 to 1. 0 to 1 means only, I mean, you can't take the 1, so it will remain as it is. I think we made some mistake in the iteration somewhere.
Yeah, at the very initial iteration, when we are going from 0 to 4, you should always check with 30 and 5 also. And they will be swapped because this 5 has to bubble up all the way up to the before after 9. Correct.
Okay, and then
So now
30.
that is the reason even if you go after that, you are not going to access that 5 at all because you are actually decreasing your I, right?
Yeah.
Yeah, that's fine actually. We can just shift that 5 before 34, right? Then we are actually good. Yeah.
Yeah, so essentially what he does is he fixes every element, right? So in the first iteration, he set 9 at the right place, right? And then he does it for 5, and then 34, 3, and 30.
Right.
So
Yeah.
as you said, it's bubble sort.
Yeah. But in
Yeah,
this, the comparison is a different one, right? Yeah. He's concatenating and comparing. That's a
Yeah,
smart way
you're
of doing it.
comparing two consecutive ones.
Yeah. Or else then we would have to do the way Parveen was saying, correct? You actually take each and every digit and then you try to do that. But that's slightly cumbersome. Yeah, it might be efficient way of doing it also. But this might be
So he
at
was
least
saying
easier.
about that bucket sort approach, right?
Mhm. Yeah,
And
as
what is
bucket sort
bucket
approach.
sort? I don't get that. What is bucket sort?
within buckets, you
That
have to
bucket sort thing he was saying, no?
Yeah, so the bucket sort will be, will have different buckets based
Okay. I
on,
mean, will that be greedy?
it's just a sorting, no?
Okay. Okay.
sorting with buckets, like
So
bucket of.
sorting in the buckets. So our buckets will be represented by the first digit in at the top level.
Yeah, but you'll pick first from your ninth one, right? The bucket which has
Yeah,
the
the
starting
highest
digit
one.
is 9.
Yeah.
So you exhaust that one, then you move to 8. So essentially looks to me like a greedy approach only.
Yeah, it's
Yeah, you can
sorting.
say so. First, do you do that sorting, and then yeah, again you'll have to have a custom comparator there too, right? Because in the case of y3 has to come before 30, 3 has to come before, so 34 has to come before 3, right? So that is one thing. So if it is a single digit, then y that has to come.
Yeah, then that would be taken care of, I think.
Yeah. So yeah. So when we
Then
go for the
basically we
two
are
digit
sorting. Mhm.
in a bucket,
Like
in a bucket
like
again we'll have to do another for 2 digit, 3 digit like that. So that will be a long way to go again.
like usually which problems do you call like greedy problems? Because now you guys are discussing and said that greedy approach won't work. Like basically like what approach you will call them as a greedy?
Greedy because you have to get the largest number, right? So you'll always try to put the max digit at front, something like that.
So
Okay,
whatever
okay.
the
So
current
sorting
state
is
is, yeah. And then based on the current state, if you are able to take a decisions and optimum decisions, right? And then it's going to give you the end result. So that is a greedy. But if you
okay,
have
okay,
to, not based on the current state, if you have to still explore all the possibilities, irrespective of the current state, and if you
okay,
then only you'll be able to get at the optimum results, then that is not greedy.
okay, okay. There we are sorting. So the maximum value is coming, then the maximum is coming. So that is a greedy. You are calling it as a greedy, right?
Yeah.
Yeah,
Yeah. Okay, okay.
Okay. So we have done this, right, Shashank?
yeah,
And the way you did a sorting, and then you join the whole thing as exactly the way you get out the output of the sorting. Correct.
Yeah, exactly. Yeah.
Mhm. Anyway, so you have to use a sort function. Either you use a sort function or you do it on your own. So if you have to do it on your own, the bubble sort is the most easiest way of doing it, right?
Yeah, it will.
Yeah. Or else use a quick sort, but and the way you are using that custom comparator, and that makes more easier.
Over there. Yeah.
Mhm.
Yeah. Then we can switch to next.
Yeah, I don't think so. There is any other solution than this one. No, we don't have any
No,
way
this is the
of
proof.
talking about. Yeah, this is a brute force, but if you go without a brute force also, yeah,
What is in the solution itself?
I think we are talking about the similar thing. What
Same
Shashank
as
there, but yeah, but they are actually using a
Yes, I'm
different
saying.
comparator, right? Yeah.
that is
It's
also
almost.
Shashank is doing. No?
He's tracking that only. Yeah. He's checking these two and then
Yeah,
depending on
come
that.
on. Just take the complexity.
Oh, what bit?
It's n log n.
For time complexity, you're saying
Yeah.
Yeah.
n log n.
So this one is better in some way.
But definitely, but it's what is doing is it's not moving.
Okay, let's do it then. You're sorting the entire map.
Far better, I think. Unnecessary, I wasted few lines.
No, let's go to the Java one.
Yeah.
We don't understand Python. Shashank.
Python has way too many inbuilt functions.
Yeah.
He's doing the same thing. He's adding these two numbers, right? And then passing it to the, this comparator function order to compare to this. And this is your comparator, right? This is what doing. Going
Yeah,
through the nums length and just checking its value of gives you the ASCII code, right?
No,
I
he's
think
just
it's
making
converting to
string out
string
of
now.
it. That's all.
String of
Yeah, then passing that in
Yeah.
the sorting comparator.
something function. Yeah. And these are the three. Like if it is equal to 0, is returning 0. And where are the other two checks? Greater than what you will return?
That's in the comparator.
Okay.
So
And
he's
it
doing
is
exactly the way you are doing, only sorting, he's using a library function. That's all.
Okay. So when he sorts it, he gets it in the descending order, right?
Hmm.
Now, where is the math happening? On line number 28.
He's appending here, concatenating.
The math happens on the top side. If you go scroll all the way to the top.
Yeah, that is the comparator, right?
Right.
So using that comparator, the person sorts on line number 19.
Yeah.
He passes
And then it's joining at the end.
he's concatenating this part. Yeah.
Yeah. So there is only one zero case on line 23.
If the first letter is equal to
Yeah.
0, then.
So this you don't have to
Then,
consider
okay.
in your condition.
Yeah.
So he's doing exactly what Shashank is doing, right? But then why is it n log n? If I
Because the
take what
sort
that like,
function, the sort function library is using a quick sort, and quick sort does within n log n.
okay.
That's the only difference.
Cool. Got it.
Yeah.
So what if it says not to use sort?
Then you have to bucketize.
Yeah, then you'll have to do what you were discussing, Praveen. Yeah. But still, that is going to
Praveen,
be a sorting, right?
yeah, Praveen. So you will have to sort them internally, no? Like if you have 3, 34, and 30, you want this to be 3, 3, 4, 3, 0, right? Then how do you ensure that?
Yeah, so that is what, no, bucket sort. See, if we first, when we go in a bucket, okay, so first the bucket, the highest level will be on the first digit. Okay, so then when we go in a bucket, like we have this 3, 34, and 30 as in a bucket of 3. So you go inside that bucket. So whichever is a single digit, in this case, 3 is a single digit. So that comes as the first one. Now you start in another bucket sort on 2 digits. Okay. So in that you again have to do a sorting there. You'll have to compare. So then in that case, 34 will come before and then 30 will come. So, but if you had more than 2, it was another 3, because then you are going to leave that, you will just take 2 digit in that case. Then you will go another level down, maybe 3 digit, 4 digits, and so on and so forth. So that again you'll have to do.
Okay, got it. So
It will be a recursive.
bucketizing on every digit.
Right, right. That is why I said it will
Yeah,
be very
sounds good, but would
cumbersome.
be complicated, I think.
Absolutely, yeah, it will be complicated. At least interview per se, what Shashank did, that will be a very good way of doing it. But to come to that, the way he is comparing as a comparator, that was also not straightforward, right?
Yeah.
Yeah.
But somehow we'll have to actually, try to understand all these tricks and maybe apply it somewhere. So therefore that is the
Yeah, and
only way, quicker
yeah.
way, I would say.
Yeah, and this string conversion is also important because you can have overflows if you take them as integers.
Right, exactly.
That's
That
something we missed
perfectly
in.
makes sense. Yeah.
Yeah.
Yeah. Ankit Jain has some questions. Right.
Hey, yeah, actually, I had one question related to the sorting. So
Yep.
here we are using the compare to method. So will it sort in descending order or in ascending order?
Okay.
Well, it is a custom comparator, right? It's not exactly the way it has to be descending or ascending, because our problem statement actually defines in a different way. So we are trying to use the way our problem is trying to compare.
It should
Okay, so
be.
in this case, since we are converting it into a string, so my understanding is that it will try to sort it in a lexicographical manner so that we can create the greatest number. Because then after
No, it's
sorting
like
it,
you take two
because here we are one first we are converting it into string, and then we are comparing the strings. So the descending and ascending order will not come into picture. It's the lexicographical order in which it will sort.
Lexicographical order based on asking, right?
Yeah, so here the strings are numbers, right?
Yeah, so
So
if you see in the chat, let's say if we have numbers 10 comma 2, so it will convert it into strings, string 10 and string 2, and then after sorting it will put 2
right.
first and then 10, and that's the lexicographical
No,
order
why is that?
because it's taking the
No, why
Unicode
is
value.
that? Why do you put two first and 10 second?
Because if you look at the implementation of compare to
No, it's
in
not.
Java,
It's taking a comparator, no, on line number 19.
yeah, but that comparator, in that comparator we are overriding the compare to method. If you look at the largest number comparator, the implementation of largest number comparator, in this we
Okay,
are
can you
using
move to
the,
that? Yeah.
This over at the rate over line number 3.
yeah, so here we are overriding the compare method, and finally we are returning order 2 dot compare to order 1. This dot compare to will take the Unicode value of each string, which is order 2 and then order 1, and then will return it. So order 2 is 210 and order 1 is 102. So it's comparing both of the strings by taking their Unicode values. And if the order 2 is greater than order 1, lexicographically, then it will return a positive value, otherwise negative value. And if both are equal, then it will return 0.
Okay, so you are saying it's comparing with 102 and 210,
Yes.
right? So 210 actually wins.
Yes. because
Oh.
that the Unicode value of 210 is greater than 102.
Yeah.
So it's not the descending or ascending order. It's the lexicographical order.
Okay, so that is the way if you are interpreting, yeah, that should be fine. Okay, but if you look at the problem statement, it is slightly more than that, you know. So if you are actually only looking at these numbers, because ultimately it comes to that, the lexicographical order also honors the integer values, right?
Yes.
Yeah. So,
Yeah.
but if you look at the problem statement, then you will come to know, because in some cases it will be slightly different when it is 3 and 30 and 3 and 34, right? So in that case, those things will have to be ordered that way. So that is why if that comparator, what you are saying makes sense, okay, it is exactly doing the same thing. It's not going to be a what you say ascending or descending, but it will sort based on what our requirements are. And if you carefully look at the description, you will come to know. If you can go to the description for a second, Shashank.
A problem description.
Yeah, problems, please. Yeah. So if you look at that example 2, right? Please scroll down a bit. Yeah. So in this case, if you look at C, you have 9, 5, then you are getting 34 and then 3 and 30. Right. So the way you get that, if you are able to follow that comparator, that's exactly fine. But if you really want to analyze it, so our 9 comes first, because here actually it is following the non-ascending order, we can say. So 9 comes first, then 5 comes, right? So as per that, all the 3 should come, right, with 34 as the first. So 34 comes, but then you should have 30 as a second, but 30 doesn't come. 3 comes and then 30 comes. So all these tricks are done by that comparator. So if you are able to
So we
follow that,
can
that's fine.
so we cannot say that it's sorting in ascending or descending order.
Yeah, we are not saying that actually, but we are trying to actually differentiate why actually the 34 is fine, but why 3 is coming before 30.
Okay.
So that the trick is done by the comparator. So if you carefully analyze that, then you'll come to know why actually this thing is making sense.
Okay.
Like Shashank,
Yeah.
Shashank here, you have used like bubble sort, right? Bubble sort technique.
Yeah.
Like, are there can't we do this like with another sorting techniques with the n log n time complexity, like less than n square time complexity?
Come again. What are you saying?
Can't we do? Can't we solve this problem with other sorting techniques, like which takes less than n square complexity?
Yeah, you can
Can we
actually.
solve or
Yeah, you
can't
can.
we? Because you are using custom comparator, right? So that I'm just asking. I don't know.
Yeah, you can. But he did it this way. He wanted to find how this works. So that makes sense,
Oh,
right?
okay,
And it
okay.
is able to pass. So it was good. Yep.
Yeah.
Because the constants are not so huge. So this is
Yeah.
fine.
Okay, okay.
But you can use, and in interview you surely will use it, right? Okay.
Yeah. I can finish to next
Let's
one.
move to the next one.
This is a maximum binary tree. So definition is like recursively you have to build and you have to create a root which will have the max value and the nums, and build the left tree on sub array prefix to the left of the max value, and recursively build the right tree sub array suffix to the right of the max value. So this is the maximum value. So 6 will be the root, and then this will be left child and this will be your right child. I mean, not child, subtree. And out of this again 3 is the maximum, right? So these 2 and 1 will be the right child of 3. So this is what happening here. 6 is the root, 3 is the left child. I mean, because this was maximum between, I mean, among 3 to 1, and once you took 3, 2, 1 went on the right side of it. And here if you check, 5 is the max, and so 5 got the privilege, and 0 is the left child of 5. Right. This is what I think they have done explanation.
Right.
Okay.
Yeah.
Just we are
Yeah.
simulating whatever they have set.
Yeah.
Normal.
So every time you should go and find in that input whichever is the largest value, right? And then you take that as a root
And
and then
left
divide.
and
Okay.
yeah, 0 to that index is left subtree, and that index plus 1 to the end is the right subtree.
Mhm. And they are specifying that we should use a recursive call also, correct?
On the top. This one.
Yeah. So everything is specified so that we can directly use a recursive
Approach there.
approach, yeah, and then we are good, right? Because
Yeah.
that becomes more easier to follow also, at least for
Mm.
this problem statement
Code
here.
will be also shorter, yeah.
Hmm.
So if I look,
So we have to take care of this minimum thing, right? That is the only thing. So the way
no
you are doing
maximum
maximum,
thing.
Mhm.
yeah, this is n square, right?
Yeah.
Hmm.
N
Will it be n
square.
square?
No, it will be more than n, and
See, it would be n square, no? So
It will be n log n, no?
let's say it's a 6 5 descending order sorted tree.
okay, worst case, okay.
Oh, it is sweet,
Then
sweet. Okay, skewed
skewed
one.
one you are
Okay.
talking. Skewed one, right?
Sorry,
I
I'm
mean,
saying ascending order only. It doesn't make sense. Yeah, I mean anything you take 1 2
Hmm.
3 4 5 6. So first root would be 6. So how do you get to 6? You travel through the entire array, right?
Mm-hmm.
Then you
yes.
make a call for n minus 1. So the
Hmm.
recursive function would be t of n equal to t of n minus 1 plus n.
No, that route, then it will give n square. T of n you are saying one you fix it and remaining n minus one needs to be fixed.
Not
So
1,
this,
n.
n minus one only, no, because one you fixed it, right? Oh, I think no, this you fixed it, so there will be two branches. It will be okay, 0 to n minus 1. Yeah, only this.
N plus n also, no? So you are doing that minimum finding.
Oh, plus oh, yeah. Okay. This will be n square.
That n is for actually finding that element. Okay,
Yes, both n square.
that will be an
Okay.
additional n there. Yeah.
Right. So I don't see this minimum thing happening in constant time. At best, we can use a segment tree, right?
Segment.
Maximum thing you are saying it will be in the O of n always.
Yeah, I mean,
Mm-hmm.
maximum it would be O(n), but we can use a segment tree and that would be log n in that case.
But
Sorry, I missed here like time complexity. Could you guys please explain the time complexity? I didn't get that properly.
yeah, see, n numbers are there, right? So initially he has taken
Yeah.
t of, out of that, let's say number was like this 1, 2, 3, 4, 5. So in order to find the max one, you will traverse this entire array. So it will be O of n.
Okay.
And you once you
Often.
found it, these many elements will go for the next call. So remaining will be t of n minus 1. And if you solved it using tree method or substitution, it will give you n square.
Okay. How come that will be O of n square then?
Okay, then
Yeah,
It
so
is
I'll
O
that
of n plus t of n minus 1, right?
you just substitute. This is n minus 1, right?
so write it as n only. Don't do it O of n.
Okay, n you write, then n will be, you replace n by n minus 1. So this will be what? T of n minus 2.
Yeah,
And this will be what? For n.
n
And now
minus
you,
1.
sorry, n minus 1. And now you replace
Add all these
this.
things.
Then, I mean,
So
with,
this is 1 plus 2 plus 3 till n. So that is n
and,
into n plus 1 by 2.
yeah.
Oh,
I
sorry,
mean,
which one you are adding? How come 1 plus 2 plus 3 plus 4?
you have to
How
write
it
more.
that will come?
Okay.
Many,
So it is a telescopic series. If you
yeah,
write some few more expressions, no, Karthik, you will figure out that all
Okay.
these terms would be cancelled, and at the end you'll have 1 plus 2 plus 3 till n.
Hmm.
Okay.
So
So
right,
I
so
have to take only t of n expression, right? I should not take any other expression.
But that
so
has
what
to
is
be
there?
evolved, no? Yeah.
You can watch his Rahula's lecture. There he has explained the how to calculate these equations using Master's theorem and
Yeah,
tree-based method.
when this can you post this in the chat or in Discord so everyone will be able
Yeah,
to.
I'll post it. There he has taken 2 hours lecture, 2, 3
Yeah.
hours. So you
Yeah.
will get the
So,
clarity.
This
so
is the
quick
master
thing,
Okay.
Karthik, the most important thing becomes only whatever that was 0 and n minus 1, n minus 2, n minus 3, it keeps on going till the last,
Hmm.
right?
Yeah.
Yeah. So that
Yeah.
actually you add that, then you'll get almost n square.
Yeah. Like in the place of t of n minus 1, we are writing this expression, right? So there it will become n minus 1. So in the
Yeah.
place of t n minus 2, again we write the expression. So like that, it will be like the remaining terms will be only n minus 1, n minus 2, like that, till 1.
Yeah.
Yeah. So it will be like n into n plus 1 by 2, it will become n square, right?
Yes.
Yeah.
Awesome.
Yeah, got it.
Thanks, Harshit. Thanks. Okay.
Thanks, bro.
Yeah.
No problem.
So this is what initial I've taken as minus infinity, right? And this is like just finding the between I to j what is the maximum number that you have seen, and just store the max index. And you take max as a root and then divide into two equal halves, right? Not two equal halves, like I to max minus 1 this way, left side, and max plus 1 to j the other way around. I mean, the next half, and you return. I mean, what we discussed, we just
So I was
simulated
thinking
it.
sorting could help, but then also it won't help, no? You won't be doing this loop thing, but essentially you will be doing that n minus 1 thing, right?
But how can we do sorting?
Orientation
Sorry.
will change, right?
Okay, yeah, my bad. Sorry, my
No,
bad.
we can't. Yeah.
Yeah, I didn't follow that. Sorry.
Yeah. I think this is the only quicker way of doing it, right?
Yeah, I think.
Yeah, this is one way. And the other way I was saying that we can use a segment tree, no? So we can make a segment tree out of it, and then we can access what is the maximum between I and j in log of n time.
Okay,
Oh,
every,
okay. You mean to
every
say
way.
all the roots of a leaf, of the leaf, who will actually have that? So then you will actually keep the maximum of all the leaves in the nodes. Huh.
Uh, yeah, I mean, just make a segment tree out of it. So what a segment tree does basically it tells us that what is the value between two indices, right?
Right.
So you can travel this tree and you can get the maximum in log of n
Mm-hmm.
because it's a balanced tree.
Overkill for this, I think. Like,
Overkill only, yeah, but I mean,
Yeah,
you
but
can just
actually you are
test.
not going to update it, right?
yeah.
No, we'll
So
just
it should
make
not
it.
be. Yeah,
Yeah,
we'll just build it, right? So that
yeah,
should
it
be
won't
fine.
be much of a heavy job, right?
Yeah,
The way you showed yesterday, Santosh, for that
yeah,
question.
right. We can use
That
that,
would be
yeah.
n log n, yeah.
That would be n log n. But in
Because
this
mhm.
case, we are actually saying if it's skewed tree, then it's going to be n square, and therefore we want to go that route. That is what you're trying to say, right?
No, in case of skew tree also, then it would be n log n because the recurrence relation we made that would be t of n equal to t of n minus 1 plus log n. Okay, so I'll annotate.
Oh, you mean to say when you go with the segmentary way?
Yeah, segment tree way.
Okay.
Can I quickly write it? Can you? Okay.
Yeah, actually, why don't you share your screen and then?
Yeah, I'll share my screen.
Right, yeah, please.
Yeah, so ignore the question.
Okay, 6:54. Okay, no problem. You can write it over there.
So we agree to this, right?
Okay, that will be log n, correct? Okay.
So now let's just make it as t of n minus 2 plus, so this would be log of n minus 1,
Yeah.
right? So after all the cancellation, what will I have? So it would be log of n plus log of n minus 1 plus log of n minus 2. So it will be going on till log of 1. Okay, so this would always be less than n
N.
times log n, right? Does this make sense? So this is an approximation.
Yeah.
This term is always less than log n, right?
Yeah.
This is also less than log n. So we only want the worst case. So we can say it as n log n.
Yeah,
And
makes
there
sense.
will be
Yeah,
n terms. Yeah.
that's perfect. Yeah.
Cool. Okay.
Yeah. Okay. Someone is asking what is a segment tree. Actually, it's a data structure. It's slightly, yeah. Right now we have not implemented it. Yeah, but if you can look at it, it's slightly advanced data structure, right? But if you really understand it, it's not a very difficult to follow. At least the basic ones.